Alright guys, let's keep going with our trigonometry and finding sides and angles in triangles. We've seen SOHCAHTOA, which works for right triangles. And just remember, anything that has a hypotenuse must be a right triangle. Like so, all of that opposite over hypotenuse, adjacent over hypotenuse, all that stuff. That really applies to right triangles, but there are some things we can do for triangles that are not right triangles. Okay, and there's two, they're called laws. There's actually, I think there's the one for tangents as well, so I think there's three, but the two main ones are the law of sines, and then there's a law of cosines. And let's just kind of see how they work, but again, keep your mind, keep thinking that, again, these are going to work for triangles that are not right triangles. That's the whole reason, because with right triangles, we already know we can use SOHCAHTOA stuff and Pythagorean theorem and all that stuff. So this just opens up the possibility to other triangles. Okay, so let's think about where it comes from. Here's just any old triangle. Again, not necessarily a right triangle. Angles are capital A, capital B, capital C, and then the sides opposite them are lowercase a, lowercase b, and lowercase c. So what I'm going to do to set this formula up here, it's kind of like a formula or an equation. Imagine if we drew an altitude and created two right triangles. Okay, I'm going to call that length h. Okay, and let me just highlight so we see the two triangles. So there's one over here. This is a right triangle, right? And there is one big one over here as well. Okay, so we have ourselves two right triangles, and I'm just going to use the regular SOHCAHTOA stuff, set up a couple equations for us. Okay, so with the little yellow triangle, would you guys agree, or you tell me, what would be equivalent to the sine of angle C? So from that angle right there, sine, just like always, sine is opposite over hypotenuse. So in that yellow triangle, the opposite side is h, and the hypotenuse is a, right? Because this is our right angle here, right? And similarly in the green triangle, if I was trying to write the sine of angle A over there, the opposite side, again, all the way across, is that same h, and the hypotenuse of the green triangle is c, right? Okay, and now I'm just going to do a little bit of algebra and try and manipulate these to get ourselves an equation. Basically, what I'm going to do on this first one here, I'm just going to multiply both sides by a. So it would be a times the sine of c equals h. Okay, I just multiplied by that a. And I'm going to do the same thing to the green equation. I'm just going to multiply both sides by c. And we will have c times the sine of a equals h. Okay, just some algebra. That's a c there. Sorry, it's a little sloppy. But then what I'm going to do algebraically, since we have, take a look at what we have, this and this both equal h, right? So remember the old transitive property, they must equal each other. So a times the sine of c must equal c times the sine of a. And now here's the little kind of the trick step that you probably wouldn't think to do, but we can divide both sides of an equation by the same thing, right? So let's just divide both sides of this by a and c. Okay, and it's lowercase a and lowercase c. They're side lengths. So for instance, let's see, can I highlight on this thing? I just want to make one thing clear. This c and this c are not the same. Okay, the one in the numerator is the angle c, but the one in the denominator is a lowercase c. So let me actually write them a little bit smaller just so we can make that connection. It's going to let me erase that or not? Oh, well. Anyways, just take my word for it. So what's going to happen, though, in the algebra is that a will cancel that a. But again, the c's don't cancel because the one is the angle measure, like a degree measurement, and the denominator is a lowercase c, which is a side length. And on the right side of the equation, that lowercase c was a side length. That's a lowercase c. But again, the angle measure is capital A, does not cancel with lowercase a. So we're left with that kind of thing. And it's basically giving us a proportion. If you look back up in the triangle, The sine of angle C right here is over its side length C will equal the sine of angle A over here over its opposite side length. And it can also be shown, just to finish the proportion, that this also works for B. So let me just finish and add to the mix here, because sometimes you'll be dealing with side and angle B. But these, why am I writing C on the bottom there? One sec. Sorry, that should be over B. Okay, and let's do a couple examples, try and clear that up a little bit. But basically, if you just remember, the sine of any angle over its opposite side length will equal the sine of any other angle over its opposite side length will equal the sine of the third angle over its side length. So again, let's go to an example and kind of clear that up a little bit. The point of all that was just showing you where this formula comes from. But here's what it can do, okay? So let's say we have a triangle like this, okay? We want to find a missing side length in the triangle. And we are given, it looks like, 2 of the angles, and we are given 1 side. Okay, so we could, of course, find that third angle. We know the angle sum's 180, and we might need to do that in this problem, because what you need to look for, we were only given 1 side length, right? So we were given that side, and the side they want us to find, AB, that's opposite from side C, so I'm just going to call it lowercase c. So the way I'm going to set this up is that there's some angle measure A, whatever this angle is, over its opposite side length, over 9, is going to equal the sine of 42 over the side that we want, lowercase c. Okay, I'm not going to use the angle 51. We don't need it, okay? And we don't know the side opposite from it. I don't know this bottom side down here. I don't know AC, so I'm not even going to really worry about that. But I kind of need to use it because notice in the equation I just wrote, we have 2 variables. And we have a way, though, of finding angle A using the 180 angle sum. So what I'm going to do is I'm going to add 51 plus 42, because those are the 2 given. I'm going to subtract that from 180. So 180 minus the 93. I know that angle A is really 87 degrees. Okay, so let's use that. This is 87 degrees. Okay, some problems they'll make you do the angle sum. Sometimes they'll just give you what you need. But let's replace angle A again with 87 degrees since we were able to find it. Okay, and the way I'm going to solve this is like any other proportion, right? We're going to set the cross products equal to each other. So for example, I know that 9 times the sine of 42. Okay, so again, it's definitely just a calculator problem with all these trig ratios. You have to use a calculator. Must equal whatever C is times the sine of 87 degrees. Okay, so make sure your calculator is set in degree mode. And we can solve this for C. All we're going to need to do is divide both sides of the equation by the sine of 87 degrees. Okay, which again, it's just some decimal that your calculator can get for you. Okay, so C is going to equal, and put this into a calculator carefully. You're going to want to do 9 and then sine. And it may open up a parenthesis. Make sure you close that parenthesis after the 42, and then divide by the sine of 87. And that should give us our answer. So let me just type this in. 9 times the sine of 42, close the parenthesis, divide by the sine of 87, and that's giving me a value for C, which is approximately, if we round, about 6.03. Okay, and that would be our side length of this side over here. Okay, and again, we didn't really have to use SOHCAHTOA because, again, we don't have a hypotenuse. We don't have a right triangle here, so we can't use SOHCAHTOA. This proportion that we set up, again, was from the law of sines, the new thing. Okay, let's do one more example. Let's say this time they give us an angle and a side, and we need to find the other side. All right, and there was one piece of missing information in there. We were also given the long side over there is 44 centimeters, okay? Because we need that. I know we need that because basically what I'm looking for to get these going, you need to have at least one angle. Oops, I don't want to highlight. We need to have at least one angle and the opposite side from it so we can set up one part of the proportion, you know, one fraction. The sine of 101 over 44 must equal, now on the other side, the other part of the ratio, we just need one of the two pieces, right? And we know the side length is 27. We just need to find that angle. So we're going to do the sine of some unknown angle over 27. Okay, so we got it set up. We did the sine of A. We actually did the left side of the equation is the sine of B over side length B equals the sine of A over side length A. Okay, and let's do the same thing. Let's do our cross multiplying, see what we get. Set up solving the proportion just like we've always done. So if we cross multiply, okay, I'm going to do 27 times the sine of 101. Let's use a little darker color there. The 27 times the sine of 101 degrees must equal 44 times the sine of the unknown angle theta, or we could call that A. And what we're going to do to solve, our first step is going to be divide both sides by the 44. Okay, I'm going to get 27 times the sine of 101 over 44. That's going to equal the sine of theta. Okay, so let's do that expression on the left. We'll just do it in a calculator. Again, make sure you have the parentheses around the angle measure. So 27 times the sine of 101, close the parenthesis. When I divide by 44, I am getting, you're going to get a decimal. It's going to be, in this case, 6024, if I round that. So that's not our answer, though. That is the sine of the answer. And just like when we found angle measures before, to actually get the number itself, we are going to have to do the inverse sine of both sides. So we're going to do sine inverse of that decimal. Okay, that's the way to get rid of sine there and just get theta. You do inverse sine, remember on your calculator, it's second sine, and then of that same decimal, and this will now give you your answer in degree mode, about 37.0 degrees. Okay, so just a little recap. Just make sure when you're setting these problems up, okay, no matter what the triangle looks like, right, it could look anything like this, you'll have three angles, and then the side lengths are lowercase, they are opposite the corresponding letter, and you want to look for one that you have a match where you know, maybe you'll know this and this, and you can just start with that one. So the sine of the angle A over lowercase a, and then just look for other ones that there may be one missing piece, but you'll know one of the two, like you might know angle B over B, and you'll know one of the two, like I said, and then the final option is, let's get another color where this can show up. How about a nice gray? That will equal the same as sine C over side length C. And you'll only use two of the three fractions, okay, just depending on, again, one of the two, you'll know both pieces, and then there'll be one where you know one of the two. And you won't use all three necessarily, you'll just need to know which two to use. But it always lines up like that, you know, it's angle over side, angle over side, angle over side. Okay, so we'll give you some practice problems and try a few out.